Hello, Charlie B here. I have been interested in cryptocurrencies for quite a few years, but I only recently had cause to actually do any coding with them. And one of the things that I discovered is that I really don't understand how they work. So I decided to teach myself, and I find that the best way to learn something is to write one for myself, and also to try and communicate it to you guys. So I'm going to create a series of videos that go through the actions of creating a cryptocurrency, all the way from transactions to blocks, all the way up to nodes. It is going to be a toy cryptocurrency, so I expect it will be full of security holes, but I think it will give at least a sketch of how Bitcoin and other cryptocurrencies work. So we're going to start with transactions. This video is going to show how to write a transaction in transaction system, I should say, in Python. But in this video we're not going to do any cryptography. It's just going to be purely looking at inputs and outputs and how Bitcoin manages those, and how we can, just through a simple list of transactions, know that we have a consistent amount of money or tokens or whatever you like. So let's get started. So the first thing we need to be able to do, obviously, is to create a transaction. So let's make a transaction. The transaction is going to have inputs and outputs. Very, very simple stuff. This is really just setting up the data structures. So what do we need? We also need data structures for inputs and data structures for outputs. And an input is going to simply be a combination of address. An input is going to simply be a combination of a transaction ID and an output number. Which reminds me, I also need him here to have the transaction ID. There we go. Now the output here is just going to be a number, because this is just going to be an array. So this will uniquely identify the output of another transaction. And we also obviously need outputs. Now, an output is going to have an address to which it's going to be output, which is actually not going to be used at this stage, but it's obviously pretty important overall, and an amount. So there you have it. Obviously we need a little bit more than this, but that's the basic data structure for maintaining consistency in terms of how many coins you have in the whole system. So what are we going to need now? We need to be able to verify that the system is actually consistent. So I'm going to do this, and BC is going to stand for blockchain, even though there are no blocks, but there will be in due course. Right now I'm just going to leave that, and I'm going to fill in some boilerplate. So, what do I want to do? First of all, let's have some example transactions so that we can, sort of understand what we're talking about. So, first of all, I'm going to create this BC, which is our blockchain, although really it's just obviously going to be a list of transactions at this point. And what I want to do is make some transactions. So, let's do bc.append. Make a transaction. It's going to have, actually this is going to be the very first transaction, so it will have an index of 0, just for my own personal convenience here, and it's also going to have no inputs. So this is going to be a transaction that's going to create some coins, and this is sort of analogous to the coin-based transactions, which is the first transaction in any block that gets mined, which is what contains the block reward. So this is sort of similar to that. So we do need to make an output, and that output is going to have an address of 1 and an amount of 100. There we go, there's our first transaction. We're going to create from nothing 100 coins. So let's create the next transaction. Now in real Bitcoin, of course, these are actually transaction IDs, which are hashes of the transaction. Here I'm just using them as basically indexes into this BC array, which is going to be pretty convenient because I can just, go to them directly in the BC array. So this transaction is going to have an input, obviously. And that input is going to be from transaction 0, and it's going to be input 0, output 0. And I'm going to give it 2 outputs. So it's going to output to address 2. And let's output 30 coins to there. And let's have address 3, and let's output 70 coins to address 3. So now we have 3 transactions, creation transaction, two transactions, a creation transaction and one that's split our initial coin creation. So let's have one more. It's going to be transaction 2, and let's take transaction 1, output 1, which is this one. So we know here we have 70 coins to play with, and we're going to give it 2 outputs as well, 4 and 5. Now let's deliberately make a mistake here. Oh, in fact, there we go. We only have 70 coins to play with. 30 plus 70 is 100, so this should be an error. Let's see. Because there is more money going out than there is coming in. Okay. Now, what else do we want to do? We can create another error. We are going to take let's see. Create transaction 3, and we're going to try and take an input 4 from transaction 4, which doesn't exist at this point. So this is going to cause an error, and then one more error. Let me see. Okay, I think that's about it. So let's verify. So what does verification mean? So the way that Bitcoin tracks the available funds to be spent is through these things called unspent transaction outputs. And if you look at a transaction here, you just have a transaction here, you have an output or a list of outputs. And in this case, when this transaction is created, this is an unspent transaction output because no other transaction has referenced it yet. As soon as this transaction shows up, this is no longer unspent, but it's created 2 more unspent transaction outputs. Similarly here, when we take this one, this guy remains unspent, and then this guy has been spent. Okay? So what we need to do as we traverse the chain is track the unspent transaction outputs, which are known as UTXOs. And I'm going to do this with a set. So let's walk the chain of transactions. UTX in BC. And what do we want to do? Well, first of all, let's figure out that the transaction itself is internally consistent, so it doesn't give out more coins than it takes in. So, input amount is 0, and we have to walk the inputs, first of all. And there's 2 things we want to do when we walk the inputs. First of all, we want to make sure that each of the inputs is unspent, and second of all, we want to sum them. So how do we check that it's unspent? Well, is that input that this transaction is claiming in the set of unspent transaction outputs? Let's see, so what do we have? We have if imp in UTX, so not in UTXOs. I'm going to print So we have attempted to spend, so either something that doesn't exist or something that has already been spent. And we'll also reference the transaction. And we're going to return false. Okay, so now we know that this input is indeed a valid input that can be used. What else we want to do? We want to just add. But this is where we're going to have some slightly complicated code. Not complicated, but not so easy to pass. So we're going to reference the blockchain, and in our input we need to get the output. the transaction ID. Okay, so now we have gotten the actual transaction data from our blockchain variable, and we need to look at the outputs from that transaction. And we need a specific output, which is the one that is referenced in the input. Okay, so now we have a reference to a specific output from a specific transaction ID, and we're interested here in the amount. So let's just go over that one more time. We have a transaction ID that we're interested in. We look it up in the blockchain. We look at its outputs. We find the specific output that we're referencing, and we look up the amount and add it to our input amount variable. Okay, so that is all of the inputs. We also need to get the outputs for this transaction to make sure that it's consistent. This is a little bit simpler, thankfully. Amount. So we're just going to sum this, and that is out amount for out in TX outputs. So again, this is just looking at the transaction that we have here and getting all of its outputs and simply adding up all of the amounts. And if out amount is greater than in amount, we have a problem. Except in one case, this special case here. So if out amount is greater than in amount for regular transactions, that's a problem. But there's a special case which we will now exclude, which is that TX inputs is empty. And what are we going to do? We are going to print an error message. Inputs are less than outputs in transaction. And let's do the same thing we did here, we did above. There we go. And if we get through all of this, we can return true because we have verified that our chain of transactions is correct. No, we need to return false here. Not very surprising. What's going on here? So I need to close this parenthesis. I also need to close this one and this one. Alright. Doesn't look like the hyphen's on a line. No. There we go. Okay. Alright, let's fix it on the screen, that's good. Okay, let's test it. I think we probably need to also actually test it. Int amount for some reason. Okay, Okay, what do we have? We have our inputs are less than our outputs. Okay, that's expected because we just did that here on purpose. So let's adjust this. 30 and 40. Okay. Yeah, I didn't read the error message correctly. It's greater than outputs because there we go. So what happened was I just reversed the logic here. So what we want to say is that if outputs are greater than inputs, and this is not a Coinbase transaction, so to speak, then we have an error. In this case, we don't have an error. Oh, okay, fair enough. This is saying that trying to use a set for where is it? Trying to use a set for inputs is not going to work. So let's turn it into a tuple. I knew there was a reason that I did this way. So we need the input TXID, and we need the input output number, right? Okay, and our first real transaction has gone wrong. And that is because I forgot a very important part of this, which is the bookkeeping. So we created this variable and we use it to verify that unspent transaction outputs exist, but I completely forgot to actually put anything in this variable, which is a problem. But not a huge problem. So we're just going to use some set operators here. So we're going to take away the set of all of the things that we just spent. So, which are these guys. For in TX inputs. Okay, so we've taken away all of the inputs that we spent, under all of the outputs that we spent, but we also added some outputs, some new ones. What to do? I'm going to add them, and it's going to be. They're going to reference the current transaction, and since we're just enumerating them, we're just going to do this. I don't care. Enumerate TX outputs. Okay. So now we're taking away the outputs that we spent, and we're adding back the new outputs from our transaction. So now hopefully we'll have something that will give us some sense. Okay, so we got through the first transaction, which is the one where we tried to spend too much, and we got to this third transaction, which is the one where we try to spend a non-existent transaction output, which is this guy here. So let's change it, but let's also be cheeky. Let's try and do a double spend. So we already spent this output, as you can see here. In fact, this is pretty much a clone for this transaction with different outputs. Great, got an error. So now let's correct this. We're going to reference this transaction, and we're going to reference the second output. Let's do 6 and 7. And we only have 40 to play with, so we're going to do 10 and 30. There. So, we have a consistent set of transactions. And that is about it for this particular video. But let me just do a quick recap. We created some very simple data structures to hold a transaction, to hold its inputs and its outputs. We created a bunch of transactions that were wrong in various ways, and eventually we corrected them. And this is really where the important stuff happens. So this is how you verify a set of transactions in terms of amount. Obviously there's no cryptography here, so we can't verify that we're allowed to spend them, just that they are available to be spent. So we walked our so-called blockchain, and we went through the inputs, made sure that the inputs were spending stuff that actually exists, and we figured out exactly how many tokens, how many coins, whatever you want to call it, are coming into the transaction, and then we figured out how many are going out of the transaction, and we created a rule that you can't spend more than you have unless you are this very special transaction that creates money or tokens or whatever. We also eventually did some bookkeeping to track all of the unspent transaction outputs and spend the ones that this particular transaction is spending, and create ones that this transaction is creating. There you go. This is approximately how Bitcoin does these things, although obviously there's a lot more to Bitcoin transactions than this, but this is a basic sketch of the layout of inputs and outputs for transactions. So thank you very much. I hope you've enjoyed this, and I'll see you in the next video.